Hello everyone, this is our session 5 on vectors. Today we are going to do scalar product of two vectors, and if time remains, then we will do vector product of two vectors as well. Let us start with scalar product of two vectors. Okay. Okay, so we're starting with scalar product of two vectors. Okay, now normally scalar product is also called as dot product of two vectors. Let us say this is a bar and b bar, and theta is the angle between them. Okay, then the scalar product of these vectors, that is a bar dot b bar, is equal to ab cos theta. Okay, so this is something that we need to remember, very important for scalar product of two vectors, where a and b are magnitudes of a bar and b bar, and cos theta is the cosine of the angle between the two vectors a bar and b bar. Now, a and b, a should be greater than equal to 0 and b should be greater than equal to 0. Now, let's look at the possibilities of angle theta. So now if theta is acute, okay, then cos theta will be positive, okay. And if if a and b are non-zero vectors, magnitudes, then the value of the scalar product will be positive. Okay, now if theta is an obtuse angle, if theta is obtuse, what will happen to cos theta? It will become negative. Okay, so cos theta will be negative, and therefore we will get the whole answer to be as a negative real number. Now if theta is a right angle, what will happen? That is, angle between the two vectors is 90 degrees, then cos product, that is dot product, would be 0. Okay, so if theta is a right angle, then cos theta is 0, and therefore AB cos theta will be 0. Okay. Now second property of scalar product is B bar dot A bar, okay, is also equal to BA cos theta, okay, which is also equal to AB cos theta. So basically, multiplying the magnitudes in any order does not change the scalar product, dot product. The scalar product is commutative. Then A bar and B bar are perpendicular, orthogonal, that is theta is 90. So what do we have the dot product as? 0. Conversely, if the dot product is 0, then the angle between the vectors is 90 degrees. Okay, now if A bar and B bar are parallel, then theta is 0. And what will be the cross product then? It will be 1. Okay, A bar dot B bar, AB cos 0, that not 1, sorry, cos theta will be 1. So if A bar and B bar are parallel, okay, then theta between them will be 0, right? So what will be the dot product then? Then we'll have B bar dot A bar equal to BA cos of 0, so which is BA. So magnitudes of the two vectors would be multiplied. Okay. Also, we have to remember by the rule of vectors that if A bar and B bar are parallel, that means A bar is equal to B bar, and therefore instead of B we can write A, and in particular we are going to get A square, can also be written as magnitude of A square. That is, answer would be square of any one vector when the vectors are parallel. Okay. Now, if you have a unit vector, then A dot A, okay, where A cap is the unit vector, what will that property be? So, A bar dot A bar is equal to A cos of 0, which is A square, and which will be 1 if A bar is a unit vector. Okay, so because magnitude of unit vector is, you can say, since magnitude of unit vector equal to 1. Okay, now so since that is 1, what can we write about I dot I then? Will be equal to J dot J will be equal to K dot K, because these are all unit vectors along the axis. So the answer would be 1. Okay. Also, now similar vectors when multiplied unit vectors, answer is 1. Now if I have I dot j, now I dot j is perpendicular to each other. right? Also j dot k perpendicular to each other and I dot k, okay, perpendicular to each other. That means theta is 90. When theta is 90, dot product is 0. Okay, so important properties while we are solving the scalar products. Okay, now expressions for a bar dot b bar in terms of ijk. That is, if a bar and b bar are given in position vector form, that is unit vector ijk form, then how do we solve the numericals? So I'm directly giving you the formula over here, that is a bar dot b bar is equal to a1 b1 plus a2 b2 plus a3 b3. That is, we just directly multiply the uh, you can say coordinates. Okay, so a1 b1 a2 b2 a3 b3. Here we are using this property, that is I dot I would be 1 and I dot j would be 0. So if you're using a bar as say a1 I cap plus b1, sorry, a1 I cap plus a2 j cap, a2 j cap plus a3 j cap, k cap, sorry, and b bar as b1 I cap plus b2 j cap plus b3 k cap. So what you can observe here is, when I do a bar dot b bar, what will I get? I will get multiplying each of this into this entire term, right? It means that when same vectors would be multiplied, I will get a1 b1, whereas when opposite vectors I cap j cap I cap k cap would be multiplied, the answer would be 0. Same applies for a2 and same applies for a3. That is why we get the final answer as a2 b2 and a3 b3. Okay, this is how you would solve it if you have to prove it. Okay, and examples, if you have the coordinates given, you write them in ijk form and then just multiply their coefficients. Okay, so that is your a bar b bar dot product when position vectors are given. Now the angle between the two vectors, so angle cos theta, okay, is given by a bar dot b bar upon ab. Okay, now which can be written as a1 b1 plus a2 b2 plus a3 b3, okay, upon ab, that is under root of a1 square plus a2 square plus a3 square into b1 square plus b2 square plus b3 square. This is how you will solve for cos theta. If the vectors are perpendicular to each other, then theta is 90 and cos theta is 0. Therefore, a1 b1 plus a2 b2 plus a3 b3 will be equal to 0. If this left hand side becomes 0, then you will get the numerator equal to 0. When will left hand side be equal to 0? When theta is 90. Okay. Now, A bar and B bar are not perpendicular to each other, then one of the angles between them is acute and the other is obtuse. Scalar product of A bar dot B bar can be positive or it could be negative but not 0. Okay, so when it's not 90 degrees, it could either be acute or it could be obtuse. If it's acute, then the cos theta would be positive, and if it is obtuse, it would be negative. Okay, so that is how you would find out the value of cos theta. Now projections. If A bar and B bar, two vectors represented by OA and OB. Okay, so let us go to the next thing, projections. What do we mean by projections? So basically we are going to take OA and OB, okay, and we'll have B bar, that is, this is vector B bar and this is vector A bar. B bar projected on A bar as point C, okay, and this is your vector A bar, okay, and theta angle here. Okay, so let OA and OB be represented by A bar and B bar and theta be the angle between them. Let BC be the perpendicular from B to OA, then OC is called as the scalar projection of B bar on A bar. Okay, OC is called as scalar projection of B bar on A bar. Okay. In right angle triangle OCB, cos theta will be equal to OC upon OB. Okay. Therefore, projection OC is equal to OB cos theta. This is how we will find out OC. So OC can be written as B bar cos theta. So projection OC bar is equal to B bar cos theta. Okay. Rather B cos theta. Now, scalar projection of B bar on A bar is equal to, okay, so this is called a scalar projection of B bar on A bar as B cos theta. Now, A bar dot B bar is equal to AB cos theta, correct? Which can be written as A into scalar projection of B bar on A bar, correct? So you can observe B cos theta is the scalar projection of B bar on A bar. Therefore, scalar projection of B bar on A bar is equal to A bar dot B bar upon A. Okay, so we can write this in this form also, A bar dot B bar upon A. This is your scalar projection. Now, if A, B, and C are three vectors, then we can write the distributive properties, that is A bar dot B bar plus C bar equal to A bar dot B bar plus A bar dot C bar. Simple like multiplication, you can do this. So basically, dot product is distributive in nature and you can use the distributive law. Vector product, when you do that is cross product, that time it's not distributive. Okay, now direction angles and direction cosines. Let's move on to that. So if L, M, N are the direction cosines of a line, then L square plus M square plus N square equal to 1. Okay, now what do we understand by direction cosines? So let us see this. So let us rotate the OX, that is a positive x-axis, in the anti-clockwise direction till it lies along the line OP. Okay, now what are we talking about over here? Let us see. So this is, let's say, your three-dimensional geometry. We have X, Y, and Z. Okay. Now here we have OP. Okay. This angle we call as beta. This angle we are calling as alpha. And let's extend OP over here on the back side. Then this angle will be called as gamma. Okay. Yes. Now let L be any line in space. So let us take line L here. Okay. Take a line OP through O parallel to line L. Let us rotate the ray OX, that is a positive x-axis, in the anti-clockwise direction till it lies along the line OP. Then we get a directed angle. So now this is your point O over here. Okay, and OX we are going to rotate up to we reach the point P. When we do that, we get the angle alpha, which is the directed angle. This angle is called the angle made by the line OP with the positive direction of the x-axis. Now, if alpha, beta, and gamma are the angles made by the line OP with the positive direction of the x-axis, y-axis, and z-axis respectively, then the line L is also said to make these angles with the positive direction of the coordinate axis. Okay, so OP is a segment from O to the point P, which is parallel to L. So whatever behavior we will do with OP, we will do with the line L. Okay, so if alpha is the line with the positive direction of x-axis for OP, then alpha is also the angle for the line L with the positive direction of x-axis. Same for y-axis and same for the z-axis. Now, These angles are called the direction angles of the line L, and the cosines of these angles, cos alpha, cos beta, and cos gamma, are called the direction cosines of the line L. Okay, they are denoted by L, M, and N. So we can say that L is equal to cos alpha, M is equal to cos beta, and N is equal to cos gamma. These are the direction cosines of the line L with the positive direction of x, y, and z axis respectively. Okay, from the above, it is clear that parallel lines have the same direction cosines. Okay, so 0 degree, alpha lies between 0 degree and 180 degree, beta lies between 0 degree and 180 degrees, and gamma lies between 0 degrees and 180 degrees. Okay. Now direction angles of the x-axis are 0 degrees, 90 degrees, and 90 degrees. Hence the direction cosines of the x-axis are. Now what does this mean, direction cosines of x-axis? It's basically the positive, or you can say, since direction cosines are defined as the angle that the line makes with the positive direction of the axis. So positive direction of the x-axis with the x-axis is 0 degrees. The angle with the y-axis is 90 degrees and z-axis is 90 degrees. So what will be the direction cosines? L will be cos alpha, that is cos 0, that is 1. Okay. M will be cos 90, that is cos beta, that is 0. And N will be cos 90, that is 0. So basically for the x-axis, direction cosines would be L equal to 1, M equal to 0, N equal to 0. Similarly for the y-axis, it will be 90, 0, and 0. So 0, 1, 0, and direction cosines of z-axis 90, 90, and 0. That is, so basically OX makes an angle with itself as 0 degrees, with OY as 90, and with OZ as 90. Similarly, OY makes an angle with the x-axis, that is alpha, as 90 degrees, with itself as 0, and with Z as 90 degrees. And similarly for the z-axis. Okay, that's how you find the direction cosines. Now, if L, M, and N are the direction cosines of a line, then we can prove that L square plus M square plus N square equal to 1. Okay. Now, proof I am not doing. I'm directly going to be using this property for our numericals. Okay. Okay. Okay, there are okay, so we have completed what are direction cosines. Now let us see what are direction ratios. So if we have L, M, and N as the direction cosines of a line, and the numbers A, B, C are proportional to L, M, and N, then we can write that L upon A is equal to M upon B is equal to N upon C. Okay, if we have this, then A, B, C, okay, then A, B, C are called as direction ratios. Okay, direction ratios or direction numbers or direction proportionals of the line. Okay, now a line may have infinite number of direction ratios. So if we have point, say P x1, y1, z1, and q x2, y2, z2, okay, and alpha, beta, and gamma are the direction angles between them, then the direction ratios of PQ, line PQ is given by x2 minus x1, comma, y2 minus y1, comma, z2 minus z1. Now there is a proof regarding this. I am not doing the proof. We are directly going to use these formulas in our numericals. Okay. Then we have relation between direction ratios and direction cosines. Okay. So let's see this relation now. Relation between direction ratios direction cosines. Now, what do we know about the direction cosines? L, M, and N. Okay, they are L, M, and N. And what are the direction ratios? A, B, and C. Then, by definition, the direction ratios A, B, C are proportional to L, M, N. So, L upon A is equal to M upon B is equal to N upon C is equal to K. Okay. Now, therefore, we can say L will be equal to Ka, M equal to Kb, and N equal to Kc. Let us say that we know from the previous theorem L square plus M square plus N square is equal to 1. Okay. Therefore, we can say that K square bracket A square plus B square plus C square, okay, is equal to 1. And therefore, what's the value of K? Therefore, K will be equal to plus minus 1 upon root of A square plus B square plus C square. Okay, now this is the value of K. If that is K, then we can write L as L is equal to Ka, right? So we can write that as plus minus A upon root of A square plus B square plus C square. Okay. M is equal to plus minus B upon root of A square plus B square plus C square. Okay. And N is equal to plus minus C upon root of A square plus B square plus C square. Okay, so we can find out the values of the direction cosines if we have the direction ratios with us. Okay, and directly we can do that. Now, if P is XYZ, any point in space, then the direction ratio of the line OP as X minus 0, Y minus 0, and Z minus 0, that is XYZ, and the direction cosines are. So let us say that we are taking any point P which has the coordinates XYZ. Then what is OP? It will be from the origin, right? So O coordinates will be 0, 0, and 0, right? So what can we say about the direction ratios then? X2 minus X1. So it will be OP. So X minus 0, Y minus 0, and Z minus 0. So we'll say direction ratios are oh, shit. Ratios are X, Y, and Z, and direction cosines are what are direction cosines? L, M, and N. Okay. Then let's say L, M, and N. So then we can write that X upon R is equal to Y upon R is equal to Z upon R. Okay. Now what is this R? Where R is equal to OP, which is equal to under root of X square plus Y square plus Z square. Okay. So direction cosines element and are given by X upon R, Y upon R, Z upon R, where R value is root of X square plus Y square plus Z square. Okay. Now, as and when we come across the problem, I will explain you how we are finding out their direction cosines and direction ratios. Okay. Because if I keep writing the formulas this way, then it's very difficult to remember all of them. The last one is acute angle between the two lines with direction cosines L1, M1, M2, L2, M2, N2 is given by. Okay, so cos theta, when direction cosines between two lines is given by mod of L1 L2 plus M1 M2 plus N1 N2. Okay. Suppose L1 M1 N1 and L2 M2 N2 are the direction cosines of the lines L1 and L2, then their angle between the two lines is given by L1 L2 M1 M2 and N1 N2. Now if cos theta is 0, that is the lines are parallel to, if two lines are perpendicular, to each other, then theta is 90 and cos theta will be 0. Then we'll have L1 L2 M1 M2 and N1 N2 equal to 0. Okay. And if the lines are parallel to each other, then they make same angles with XYZ axis respectively. Therefore, their direction cosines are same. Means L1 equal to L2, M1 equal to M2, and N1 equal to N2. Okay, if they are parallel to each other. Here, now if A1, B1, C1, and A2, B2, C2 are the direction ratios of these lines, then the above condition takes the form. So if we have A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. Okay, so this is the ratios of the direction ratios of the lines given to us. That's the direction ratios are proportional if the lines are parallel. Okay, and if direction ratios are given and lines are perpendicular, then we will have A1 A2 equal plus B1 B2 plus C1 C2 equal to 0. Okay, so if lines are parallel, then the direction ratios are proportional. If lines are perpendicular, then their sum of their products is 0. Okay, this is what was left of the properties. And the next session we will do sums regarding these scalar properties that we have learned, scalar product properties. Okay, if you have any doubts in the explanation, do write to me.